Hi friends, welcome back to our RxJS tutorial series. In the previous video, we learned how to create observables using functions such as off, from event, interval and timer. But creating an observable is only the beginning. In real-world applications, we usually don't subscribe to an observable immediately after creating it. Most of the time, we need to process the data before it reaches the subscriber. For example, we may want to transform data, we may want to filter out unwanted values, we may want to ignore duplicate values, we may want to wait until the user stops typing before making an API call, and we may want to log data for debugging purposes. This is where RxJS operators become extremely useful. In this video, we will learn some of the most commonly used RxJS operators and understand how they help us process observable streams efficiently. Let's get started. Think of an observable as a water pipe. Data continuously flows through that pipe. Now imagine attaching different filters to the pipe. One filter removes unwanted particles. Another filter changes the water in some way. Another filter controls when the water flows. RxJS operators work in a very similar way. They sit between the observable and the subscriber and process the data before it reaches the subscriber. Before we start learning operators, there is one important concept you need to understand first. That concept is pipe. You may remember that in the previous video, when we used debounceTime and throttleTime, we also used pipe. At that time, I didn't explain it because I wanted to keep the focus on observable creation. But before learning operators, it's important to understand what pipe does. Whenever we want to apply one or more operators to an observable, we use the pipe method. The pipe method allows us to connect multiple operators together and process data step by step before it reaches the subscriber. You can think of it as a processing pipeline. Each operator receives data, performs some work, and then passes the result to the next operator. Before RxJS 6, operators were chained directly as methods. For example, observable.map.filter. While this worked, it made the RxJS library larger and harder to optimize. The pipe method was introduced to solve this problem. Today, pipe is the standard way of working with RxJS operators. The pipe method accepts one or more operators as arguments. These operators execute one after another. The output of the first operator becomes the input of the second operator and so on. This creates a data processing pipeline, and that's exactly why it is called pipe. Now that we understand pipe, let's start learning operators. We will begin with one of the most commonly used operators, map. The map operator takes each value emitted by an observable, transforms it, and emits the transformed value. If you have worked with JavaScript arrays before, it works very similar to array.map. Let me show you an example. First, I will create an observable using the from function. If I subscribe to it and print the values, we can see the original data being emitted. Now let's say I want to transform the data before displaying it. For example, I want to multiply every value by 10. This is where map becomes useful. First, we use the pipe method. Inside pipe, we add the map operator. Here, we transform each emitted value by multiplying it by 10. Now let's preview the application. As you can see, we are getting the transformed values. One important thing to understand is that map does not modify the original data. Many beginners think the original values are being changed. That is not true. The map operator creates a transformed value and emits it. The original data remains unchanged. Let me prove that. I will duplicate the same code and remove the map operator from the second observable. Now if we preview the application, we can see that the original values are still the same. This confirms that map only transforms the emitted values and does not change the original source data. Now let's look at a more practical example. One of the most common uses of map is processing API responses. For example, we might want to extract usernames, format dates, convert currencies, create view models for the UI. Let's create an array of user objects. Suppose we only need the usernames. Instead of sending the entire object to the subscriber, we can use map to extract just the name property. First, we will convert the array into an observable using from. Then we will use map to return only the username from each object. Finally, we will subscribe and print the result. If we preview the application, we can see that only the usernames are being emitted. This makes the data much easier to work with. So to summarize, the map operator is used to transform each value emitted by an observable into a new value. It does not modify the original data. Instead, it creates a transformed version and passes it to the next operator or subscriber. And because data transformation is such a common requirement in real-world applications, map is one of the operators you will use very frequently. Okay, let's move on to another commonly used RxJS operator, filter. First, let me comment out these lines so that we don't get unnecessary output in the console and confuse ourselves. Now suppose my requirement is to display only the even numbers from this observable. For that, we can use the filter operator. The filter operator allows only the values that satisfy a given condition to pass through. If a value matches the condition, it is emitted. If it doesn't match the condition, it is ignored. Think of filter like a security checkpoint at an airport. Only people who meet the required criteria are allowed through. Everyone else is stopped. Let me show you how it works. I will copy this code. Then I will replace map with filter. Inside filter, we need to provide a condition. Since we want only even numbers, I will use this condition. This condition checks whether the number is divisible by 2. If the condition returns true, the value is allowed through. If it returns false, the value is filtered out. Now let's preview the application. As you can see, only the even numbers are displayed. Pretty straightforward. Let's look at another example. We have this array of users. Suppose we want to display only the users who live in India. First, let me copy this code. Before extracting the names using map, I will use filter to keep only the users whose country is India. Like this. Then after filtering, I will use map to extract only the usernames. Now let's preview. As you can see, only John and David are displayed. This example also shows another important concept. Operators become much more powerful when they are combined together. Here, filter first removes unwanted users and then map transforms the remaining data. This is one of the biggest strengths of RxJS. The main advantage of filter is that it removes unwanted data early in the pipeline. Instead of processing every value, we only process the values that actually matter. This makes our code cleaner and more efficient. I hope filter is clear. Now let's move on to another very useful operator, tap. The tap operator is used to perform side effects on values flowing through an observable stream without modifying those values. But what exactly is a side effect? A side effect is simply an action that happens while processing data. Some common examples are logging values, debugging, showing notifications, sending analytics events, tracking API calls, and updating monitoring tools. The important thing to remember is this. Tap does not change the data. It can see the data, but it cannot modify the data flowing through the stream. Think of tap as a CCTV camera. The camera watches everything that happens, but it does not interfere with anything. Let me explain with an example. First, let me comment out this code. Now let's create a pipeline. I will use filter to keep only the values greater than or equal to 5. Then I will use map to multiply each value by 10. Finally, I will subscribe and print the result. Let's preview the application. We can see the final transformed values. But what if you want to see what is happening inside the pipeline at each stage? This is where tap becomes very useful. Let me add a tab after filter and before map. Then I will add another tab after map. Now let's preview again. Notice the output carefully. The first tab shows the values after filtering. For example, the value 5 passes through the filter. Then map transforms it into 50. The second tab shows the transformed value. And finally, the subscriber receives that same transformed value. The same process happens for every emitted value. So what is tab doing here? It is simply allowing us to inspect the data at different stages of the pipeline. It helps us understand exactly what is happening inside the observable stream. And because of this, tap is one of the most useful operators for debugging RxJS code. Whenever something is not working as expected, adding tap operators at different stages can help you quickly identify where the problem is occurring. So to summarize, tap is used to observe values and perform side effects. Tap never modifies the data. Tap is extremely useful for debugging and monitoring observable streams. Hope you understand tap. Let's move on to the next operator, take. The take operator allows us to receive only a specified number of values from one observable. Once that number of values has been received, RxJS automatically unsubscribes and completes the observable. Let me show you an example. First, I will comment out this code and copy our previous example. If we preview now, we can see that all values from the observables are being emitted. Now let's add the take operator. Suppose I want only the first 5 values. I can do that like this. Now let's preview again. As you can see, only the first 5 values are displayed. The remaining values are ignored. After receiving 5 values, the observable automatically completes. This is one of the reasons why take is so useful. Let's look at a few practical use cases. Suppose a user clicks a button multiple times, but you only want to process the very first click. You can use take of 1. Or imagine you are subscribing to an API response and you only need the first value that arrives. Again, take of 1 is a good choice. The biggest advantage of take is that it automatically unsubscribes once the required number of values has been received. This helps reduce the risk of memory leaks and makes subscription management much easier. Now let's look at another operator that is closely related to take. That operator is skip. The skip operator does exactly the opposite of take. Instead of taking the first n values, it ignores the first n values. After skipping those values, it starts emitting everything that comes after. Let's use the same example. Instead of take, I'll use skip. If I pass 5 to skip, the first 5 values will be ignored. Let's preview. As you can see, the first 5 values are skipped and only the remaining values are displayed. At first glance, skip may seem like a less useful operator. You might be wondering when you would actually use it in a real application. Let me give you a practical example. Suppose you have a form control. When the component loads, the form control may emit its initial value automatically. Sometimes we don't want to react to that initial value. We only want to react when the user actually changes the value. In that situation, skip of 1 can be very useful. Similarly, state management libraries often emit an initial state when a component subscribes. If that initial state is not important for your business logic, you can skip it and start processing only future updates. In general, skip helps us avoid running unnecessary logic for initial or irrelevant emissions. So, to summarize, take receives only the first n values and then automatically completes. Skip ignores the first n values and emits everything after that. Take is useful when you only need a limited number of values. Skip is useful when you want to ignore initial emissions. I hope both take and skip are clear. Now let's move on to another very important operator, debounceTime. However, I have already explained debounceTime in detail twice in our previous videos. In fact, the search box example that I showed in the first video and the previous video is one of the best real-world examples of debounceTime. So instead of repeating the same explanation and making this video longer, I'm going to skip the detailed explanation here. If you haven't watched those videos yet, I highly recommend checking them out because they provide a complete understanding of how debounceTime works and why it is so useful. Just as a quick reminder, the debounceTime operator waits for a specific period of inactivity before emitting a value. If another value arrives before that time period ends, the timer resets and waits again. This makes debounceTime perfect for scenarios where events occur very frequently. Some common use cases include search boxes, autocomplete suggestions, form validation, reducing unnecessary API calls, user input processing. You will see debounceTime being used extensively in real-world applications. Okay, let's move on to the last operator we will cover in this video, distinctUntilChanged. The distinctUntilChanged operator emits a value only when it is different from the value emitted immediately before it. In simple terms, it prevents consecutive duplicate values from being emitted. This operator is very commonly used in applications to avoid unnecessary processing and duplicate API calls. Let me explain it with a simple example. First, I will comment out this code and create a new observable that emits the following values. Now, let's subscribe to it and preview the application. As you can see, 1 is emitted twice, 2 is emitted twice, 3 is emitted 3 times, and 4 is emitted once. Now let's apply the distinctUntilChanged operator. If we preview again, we can see that only one occurrence of each consecutive value is emitted. The output becomes 1, 2, 3, 4. At this point, it's important to understand something. Many beginners think distinctUntilChanged removes all duplicate values. That is not true. It only removes consecutive duplicates. Let me demonstrate. I will add another 2 at the end of the sequence. Now let's preview. Notice that 2 is emitted again. Why? Because the previous value was not 2. The previous value was 4. Since the current value is different from the immediately previous value, it is allowed through. This proves that distinctUntilChanged only compares the current value with the previous emitted value. It does not remember all values that were emitted in the past. One of the most common places where you will see distinctUntilChanged used is alongside debounceTime in search functionality. Here is what happens. First, debounceTime waits until the user stops typing. Then distinctUntilChanged checks whether the search term is different from the previous search term. If the value hasn't changed, it is ignored. As a result, duplicate API calls are avoided. This combination is extremely common in applications. Now let me ask you a question. What do you think will happen in this example? Many developers expect the second object to be ignored because both objects contain the same data. However, this is not what happens. Both objects are emitted. The reason is that distinctUntilChanged uses strict equality comparison by default. Even though the contents look identical, these are actually two different object references in memory. And since the references are different, distinctUntilChanged treat them as different values. This is a very common interview question and a common source of confusion for beginners. Another practical use case is working with WebSocket streams. Imagine a server continuously sends updates. Sometimes the same data may be sent repeatedly. Using distinctUntilChanged, we can react only when the data actually changes and ignore duplicate consecutive updates. Some of the major advantages of distinctUntilChanged are reduces unnecessary API calls, improves application performance, prevents unnecessary UI updates, reduces redundant processing, and it works very well with debounceTime in search scenarios. However, it also has a limitation. The biggest limitation is that it only checks consecutive values. If the same value appears later in the stream after other values, it will be emitted again. So keep that behavior in mind when using it. I hope you now understand how distinctUntilChanged works and when to use it. Alright, that's all for this video. Today, we explored some of the most commonly used RxJS operators. We learned map for transforming data, filter for allowing only specific values, tap for logging, debugging, and other side effects, take for limiting the number of emissions, skip for ignoring initial values, debounceTime for delaying emissions until user activity stops, and distinctUntilChanged for preventing consecutive duplicate values. As you have seen throughout this video, operators are what makes RxJS truly powerful. They allow us to transform, filter, control, and manage data streams in a clean and declarative way. These operators are heavily used in real-world applications, especially when working with forms, user input, API calls, search functionality, and asynchronous data. By understanding these operators, you are already building a strong foundation in RxJS. In the next video, we will move on to some of the most important RxJS operators that are frequently asked about in interviews: switch map, merge map, concat map, and exhaust map. We will understand the problem each operator solves, how they behave differently, and most importantly, when to use each one in applications. Trust me, mastering these 4 operators will take your RxJS skills to the next level. If you found this video helpful, please hit the like button and share it with your friends. And if you are new to this channel, don't forget to subscribe and support the channel. Thank you for watching. See you in the next video. Bye.